Hello guys, my name is Ijlal Ajwal bin Hassanuddin and my ID number is EP01077727. So this is my final project, which is synchronous counter by using my ID number, which is 01077727. So we proceed. There are some steps how to design synchronous counter. So the first one is decide number of flip-flops. The second one is choose type of flip-flop and its excitation table. The third one, state diagram and circuit excitation table. The fourth one is obtain simplified equation using K-map. And the last one is draw the logic diagram based on the K-map, based on the equation that we get from the K-map. So the first one, how to decide number of flip-flops. So before I decide how many number of flip-flops, I need to know how many bits that I need to use. So based on my ID number, so it's 01077727. So this is sequence. So the first one is 01077727. So based on this one, the left one is the binary number. So based on my number, we can see that there are some repetition of number 0 and number 7. So if I use this sequence or this binary for my counter, there will be an issue, which is issue when we do in the K-map, because we cannot do K-map two output in one input. So how I want to overcome this issue is by using 5 bits, but we need to make sure that the last 3 bits must be the same like the original one. So we can see in the black box, we can see that the value of binary is still the same, but the two binaries in front it's not the same. Just put any number as long as it's not the same. So when we do the circuit diagram, the output, we just take the output for the 3 bits first in the black box. For the green one, we just ignore, because this output we don't need for the output for the binary later. So based on this one, you can see that we use 5 bits. So it means that when we use 5 bits, it means that we use 5 flip-flops. So next, choose type of flip-flop and its excitation table. So for this project, I will use T flip-flop because it's more easier to design the counter, because T flip-flop just include the T, Q and Q bar. That's only. So this is the excitation table. So Qn here means that the present state, and Qn plus 1 it means the next stage, the next state, and T is the input. So you can see if the 0 0, so the T will be 0. So when the 0 1, the T will be 1, and T 0 will be T, and T and 1 1 will be 0. So next, state diagram and circuit excitation table. So based on the sequence just now, we will use this sequence, which is 0 1 8 7 15 2 2 3. It means that it's 5 bits yet. So the state diagram, the first one is 0, right? So 0 means that 0 0 0. Next we move to the 1, which is 0 0 1. The second one is 7, which is 0 1 0 0. Next one is 15, 0 0 and 7, 0 0 1 1. 15, which is 0 1 1 1 1 1. Next one is 0 0 1 0, and the last one is 23, which is 1 0 1 1. But after 23, it will be back to 0, which means that sequence will keep repeat. When is they already done with the sequence, it will be repeat back. So next, after we done with state diagram, we move to the circuit excitation table. So based on this table for the present state, and next that we just follow the state diagram. For example, for the present state, for the first row, you can see that 0 0 0, right? So we can see here is 0 0 0. So the next state, just follow this diagram, which is 0 0 1. So this one is 0 0 0 1. So back to present state for the second row. So present state right now is the next state here, right? So it means that the present state right now is 0 0 0 1. So after 0 0 1, you can see in the state diagram, we move to the 8, which is 0 1 0 0. So we put here the next state 0 1 0 0, and back to the present state, which is right now, which is same 8, which is 0 1 0 0, and move to the number 7. So this part for the present state and next state, we just follow the state diagram. So for the the input here for T, we must follow based on the excitation table of the flip-flop. So how we want to do this, for example, for the T4, the first row here, T4, the blue one. So we need to look at the Q4, the blue one here, present state, and the next state, Q4 here. So we can see here is 0 0. So we look at the table, excitation table, you can see is 0 0, it will be 0. So it means that T4 here is 0. So for other example, for the Q0 here and Q0 here, the black one. So we can see the Q0 is 0 for the present state, and the Q0 is 1 for the next state. So refer to the excitation table, we can see that when the Qn 0 and the state is 1, so the T will be 1. So that's why the T01 is here. So just follow all the excitation table of the T flip-flop. So this is our final answer, final result. So done with the second excitation table. So the fourth one is obtain simplified equation using K-map. So we do the K-map based on the T flip-flop here. We can see the table T. We have T4, T3, T2, T1, T0. So we will have 5 K-maps. So the first K-map, which is T4. So here is the equation, which is Q1, Q0 bar, and Q4. So the first term here is for this group, and second term is this group. So this is our T4. Next, move to T3, flip-flop 3. So here is our final equation. So we have 2. So the first term is this group, and for the Q3 is this group. So this is our T3. Move to the T2. So T2 we have 3. So the first group is here, the second one is here, and the last one is here, Q4. Okay, we're done with T2. So move to the T1. So T1 we have 2 terms. So the first group is here, and the second group is here, Q4. And the last one is T0. So that we have 3. So the first here is our equation, our group. So done with the K-map. So lastly we can draw the logic diagram. So for the logic diagram, we will use 5 flip-flop. So we can see that we have 5 T0, T1, T2, T3, T4. So the first one will be T0, the second one is T1, the third one is T2, the fourth one is T3, and the last one is T4. So this flip-flop will be constructed based on the K-map what we get just now. So here is the result. So the next one, we need to make sure that the clock of this flip-flop must be the same. So we can see here all the flip-flop here is connected to the one clock, which means synchronized counter, synchronized flip-flop, because all the flip-flop are used based on the same clock. So for the output, for the T0, Q0 and the T0 will be the least significant bit, while the T2 here, which is Q2 here, will be the MSB, which is the most significant bits. So for the last 2 bits, the 2 flip-flop Q, we will just ignore, because what I told just now earlier slide, we just ignore the bits because we do not use it as our counter. So here's our output here. You can see that 1 1 1 here. So our output. So the right one will be LSB and MSB. So just follow the flip-flop that I already labeled here. So this is the way we will read the sequence based on this flip-flop. So I will move to the simulation. So this is my circuit. It's already constructed circuit diagram in the Circuitverse website. So it's already work. So how we want to to ensure that this circuit is correct or not? So we just look at the output here. So the output here already in the binary form, which is binary form. Sequence is follow our my ID. So we can check here. So this is 0. Wait, we can just wait. So my ID number is start with 0, right? So 0 here, 1, 0, 7, 7, and 2, 7, 0, 1. So it's already follow my sequence, my ID number, and it keep repeating. So it means that this circuit is correct by using T flip-flop. T flip-flop. So it means that this circuit is correct and the circuit is also correct. So done with simulation. So next we move to the additional part for the bonus part, which is reverse sequence by using other type of flip-flop. So we will choose two bonus, which is reverse sequence, and use other flip-flop. So the first step, like usual, decide number of flip-flop. So based on the sequence just now, this right 0, 1, and 7, 15, 23. So the bonus one is to do the reverse sequence. So just reverse like in the slide 23, 2, 15, 7, 8, and 1, 0. We just reverse it. So this is our bits. So there are no change, no difference with the earlier project just now. We still the same bits, which is 5 bits. The difference is just for the sequence. We start with 23 and the last one is 0. So we use 5 bits, it means that we use 5 flip-flops. So the second one is choose the type of flip-flop and its selection table. So for this part, I will choose other type instead of T. So I use D flip-flop because it's also easier to construct the circuit diagram. So here the selection table. So it's quite different with the T flip-flop for the especially for the result of this one. So next, state diagram and circuit execution table. So for this sequence, we just follow this one, which is 23, 2, 57, 8, and 1, 0, because we need to reverse it, right? So we move to the state diagram. So the first one must be 23, which is 1, 0, 1, 1, 1. The next one is 2, 0, 0, 1, 0. Next 15, 0, 1, 1, 1. Next one is 7, 0, 0, 1, 1, 1. Next is 8, 1, 0. And back to the 23. So done with state diagram, we move the circuit excitation. So this circuit excitation table just the same like previous slide. So just refer, just different in for the part of D here. So this one, the result must be follow or refer to the excitation table of D flip-flop. So they are different for this one, must follow this one. So it's not the same like T flip-flop. So the result also will be not the same. So done with the excitation table. Next we move to the K-map. So the first D is D4. So one term only. So this is the first group. And D3 is the equation, the simplified equation. So D3 we have 2. So the first one is here, and the second one is here. So move to the D2. So we have 2. So the first one is here, the first group, and second group is here. And D1. So we can see we have 3. So the first one is first group here, the second group, and the third group. So we have 3. And the last one is D0. So we have 2. So the first group is here and the last one is here. So we done with the K-map. So the last part is draw the logic diagram. So they are different here. We use D here, so we can see D here. So the arrangement is still the same like the previous slide. For the toggle T flip-flop, so the first must be the D0, D1, D2, D3, and D4. So for the circuit here, must just follow the boolean, simplified boolean we do just now on the KMap. So done with that, we will make sure the clock is synchronous, which means that all the flip-flop is connected to the same clock. And for the output, same situation. The first flip-flop will be the first Q, will be the LSB, and the D2 will be the NSB. And we do earlier, so the D3, which is the 03 and 04, we just because the bits we didn't use it for the sequence, our sequence. So this is our output reading for binary. So MSB, LSB. So we need to make sure the MSB is on the right and LSB is on the left, because most significant bits must be in front and the last bit will be at the back. So we have 001 here. So here is we want to read the output. So we move to the simulation. So hello. So this is my last part. So the simulation for the reverse sequence by using the flip-flop. So I already construct the diagram here in the circuitverse. So here's my circuit, and the output is here already in binary form. So we want to check whether it's correct or not. So it must be reverse sequence, and we can check here. So okay, so the first one is 7. So 7, move to the 2, move to the 7, move to the 7, move to the 0, move to the 1, and move to the 0, and repeat back to the 7, 2. So it means that our sequence for this sequence is correct, which means that it follows the reverse sequence of my ID number. So it means that this circuit is correct by using a D flip-flop. So done with my simulation. So that's all from me. Thank you.